Ho ho ho, and welcome again to another room here on TryHackMe. We are looking at Advent of Cyber. It's day number 5. SOC-mas XX-what-ee. So we are dealing with a red team room today. And I'm going to try and zoom just a tad so we better can read it. Now the learning objective is going to be to understand XML stuff, to explore XXE and the XML External Entity and its components, learn how to exploit the vulnerability and understand remediation measures. Important concepts. So extendable markup language, it's a commonly used method to transport and store data through format that humans and machines can easily understand. So consider a scenario where two computers need to communicate and share data. Both devices need to agree on a common format for exchanging information. The agreement format, also known as XML, you can think of XML as a digital filing cabinet. Just the filing cabinet that has folders with labeled documents inside. XML uses tags to label and organize information. These tags are like folders that define the type of data stored. That's what the XML looks like. So down here below, we have a standard format of XML, like people, name, address, phone, and so on. So basically, it's kind of like an object, if you know programming, where you put an object called people and then some different kind of variables inside of the object. So that's what we kind of talked about right there. The document type definition of the DTD, which is defining stuff. So now that the two computers have agreed to share data in a common format, what about the structure of the format? Here is when the DTD comes into play. A DTD is a set of rules that defines the structure of an XML document, just like database scheme. It acts like a blueprint, telling you what elements, tags, and attributes are allowed in the XML file. Think of it as a guideline that ensures the XML document following a specific structure. So for example, if you want to ensure that an XML document about people will always include name, address, email, phone, and number, you would define a rule set just like this below. You might have questions to this, but this is the way it is done. So basically we just have to say like, yeah, this is the rule set, basically telling us that this is how it's done. Of course, the questions could be, what about this and that, and duplicate phone, what is that all about? So let's continue reading. In the above DTD, element defines the element tags that are allowed. So element tag, like name, address, email, phone, whereas the the PC data stands for past people data, meaning it will consist of just plain text. So this is basically a way of saying we need text there. It's just the way it is. You know, I know the names are weird, but yes, just the way it is. XML is an old thing. Entities. So far, both computers have agreed on the format, the structure of data, and the type that data need to share. Entities in XML are placeholders that allow the insertion of large chunks of data, or referring internally to external files. They assist in making the XML file easy to manage, especially when the same data is repeated multiple times. Entities can be defined internally within the XML document or externally referring data from an outside source. For example, an external entity references data from an external file resources. In the following code, the entity at ext could refer to an externally file located at right here, which would be loaded into the XML if allowed by the system. So we see here that we have some sort of a variable, and we're going to put it inside there. So I think I know what the exploit is going to be all about here in the red team setup, but I'm not going to spoil anything. Let's just continue to read about it and learn as we go. We are specifically discussing external entities because this is one of the main resources that XXE is introduced if it's not properly managed. So XML External Entity XEE. So after understanding XML and how entities work, We can now explore XXE Vulnerability. XXE is an attack that takes advantages of how many XML parsers handle external entities. When a web application processes an XML file that contains an external entity, the parser attempts to load or execute whatever resource the entity points to. If necessary sanitation is not in place, the attacker may point to entity to any malicious source code causing the undesired behavior of the web app. So we are back to having, classic sanitation of the input, which is also something you can do through an analysis type called a taint analysis, which is not a part of the room, but go ahead and check it out on my channel if you want to learn about that. It's called taint analysis. So for example, if a vulnerable XML parser processes the external documents like this, so we can basically say like our TryHackMe file from somewhere will be inputted there. So depending on what is going on, in this particular case, we will look at the parsewd file. Now, what if it could be the shadow file on Linux machine? Well, that would be pretty catastrophes, I guess. So here the entity refers to sensitive data, XML, etc password file, which the XML is processed. The parser will try and load the display data in a file, exposing sensitive information of the attacker. So really that's how that works in particular case. We are connected, we started the machine, and the practical thing. So now we understand the basic concept of related XML and XXE. We will analyze an application that allows users to view and add products to their cart and perform the checkout activity. We can access the Wareville application hosted at. So we're going to take the IP address, and I'm going to see now if the copy paste work today. I know I definitely should split the windows or use this a little more, but I definitely don't want to do that if I can avoid it and just copy paste. So we're going to try and put in the IP address. It is going to access TryHackMe, so I guess that's just automated. Let's go ahead and access this. So now this is where we have our WishVille web design. So flow of the application. As a pen tester, it is important to first analyze the flow of the application. First, we will user will browse through the products and add items of interest into the wish list. So let's go to products.php, click the product link, and click on add to wish lists under Wareville's Jolly Cap. This is the one right there. So add to wish list. Now it's being added to the wish lists. This is how it's shown. So after adding the product list, click on cart, which is there. The bottom with widget. So on the cart page, click the proceed to checkout. So we're going to click proceed to checkout at the item below. And on the checkout page, user will be prompted to enter the name and address shown below. So we can basically enter the name of my choice. I can write Dan, and our choice address is just going to be Fantasy Road. I need to spell that correctly. 1, 2, 3, and click complete. And now with success, your wish has been saved as wish 21. And this is where we can probably indicates that the wish is placed by the user on the website. Once you click it, you will see a forbidden page because details are only accessible by admins. So if we click that and open in a new one, we are being we cannot do that because Santa's elf are the only ones that can read wishes, even though we have the link. So now we have this, we need to intercept. So let's go ahead and start Burp, which is one right there, the blue one. Burp is a web proxy. It will intercept the requests and the replies from the web server. So the request we're sending to the web server, we can intercept that before we send it, and we can intercept the replies we get from the web server in Burp, making it possible for us to do any final alterations or view the data as they are in raw format before being inserted to the browser. Now I'm using the attack box in this particular case because, well, it's just easier that way. Click next here and start Burp. And in the attack box, we have Foxy Proxy installed. Foxy Proxy is the extension that can easier make us direct all traffic from the browser to the Burp. And if you don't know how that works, it's basically just installing Foxy Proxy in your Firefox browser, and it's an extension, and then go to in this particular case here we need to add a new one, and I guess it's already added here, of course. Let's just close that down, and you need to press the one called Quick Add. And if the first time you do this, it's not working here on the machine. I don't know why, but you probably get it. You have to add the IP address of 127.0.0.1 and the port of 8080, and just enable it by going to click it, and then it says Burp, and then now we direct all traffic to Burp here. And now we have to go to target, proxy, intercept is on, intercept off. Now that it is on, I can go to web page, click it, and we can see that it did pop up here down below with the actual request. I know it's a bit small. I don't think I'm able to zoom on this in any way. You can see like trying that and then search for the word called font. See if we can increase the font size. Let's just do 18. And it's pretty slow. Apologize for that. It is just the way of, this. So now it's bigger. Now we can probably see it a bit more, but we have the, I just need to remove this update on next restart. Yeah, so we have it. It's a bit small, but we can see the request right there. It's something Google. We have the one here on the web server. And what we can do is we can right click the request and send that to, for example, something like repeater. Then we can, of course, drop the intercept by clicking the button, go back to repeater, and then we can see the raw request here. Of course, the text hasn't been zoomed here. Can I zoom it anyway? No, I cannot. No, I cannot zoom in this. But you can see this is the get checkout, and I apologize for the size. It's just the way it is. And here we can basically just send it, and then we get a reply back as a response. We can go to raw, hex, or render, and render will then try and render whatever request we get back, reply, sorry. The raw one is usually a bit more interesting because then we can see the actual HTML we're getting back from the request, and we can then go through it all and see what we get. But in this particular example, let's go ahead and do what they say in the tutorial. So we'll use the Burp suite. So use the attack box. Once you click the button, just welcome next and next, as was shown before. And now we're gonna use, and we'll see the three main interface tabs such as proxy, intruder, and repeater. The proxy one is where we are setting up the actual connection, so now we're intercepting or not. Intruder is some automated brute force capabilities, and repeater is something we just use so we can just automatically send and edit the different kind of requests we're sending to the web server. Inside the Burp suite, we can click settings. Let's just do what it says. So settings, and you will see the Burp option available under tools. to do this there under tools, enable allow under tools there. I'm gonna say you'll see Burp's browser options available under tools. So Burp browser options there. Enable allow Burp's browser to run without a sandbox option. So we're gonna click this one there. And I know it's a bit small, but it is, there we go, the way it is. And now it is saved. To check if the settings go through, click on settings again, scroll down and see it is right there. Now that it is saved, let's go and continue with the tutorial. So now we can click the close icon in the top right corner of the settings tab. So now we close that. We're going back here. So after allowing the browser to run without a sandbox, we will now be able to start the browser with pre-configured Burp Suite proxy, navigate to the open browser, and locate the proxy intercept of Burp. Open the browser by clicking Open Browser as shown below, and to use into UL. So what I want us to do right here is basically to go into proxy and click the one here, Open Browser. When we do that, we will open a browser that is connected to Burp already, and we can use it as the same way as we did on the Firefox. So if that is what you want to do, you can do that. Open Browser will then open a browser. If it works, I guess. I'm not really going to do that in all honesty, but we have this Burp Suite Chromium. Well, we can use it, I guess, if you want to do that. Open the browser, the URL. All requests intercepted through can be on the proxy history. So all the intercepts can be viewed again there if that is what you want to do. Now I opened 2 of them because I clicked it twice. That's not the best idea. So now that we did that, let's go ahead and visit the page one more time. So put in the IP address in this particular browser right there, and click on products, add to wish list. Just, let's see, products, and then add to wish list. An HSCal call is made to add the wish list with the browser following XML. We can check that out by going to let's see, did we do everything? Yes. And somewhere we could see all these kind of things. HTTP history. And we have a wish list right there, as a PHP thing. We can go ahead and check that out and see here down below that we have the wish list that we actually just clicked on. If we now go back again to the same and go to products and then do this one here and go back one more time and scroll down, we can see a new line appeared on the product. We visited that site and the wish list, and then we added the product number 2, and the first one was product number 1. So we can see that while we interact with the website through Burp, we can follow along with what XML is sent back and forth. Which is also what this show right here, actually. So the wishlist PHP accepts the request and passes the request using the following code. So we have this code right here. Now we are being handed this. We don't usually see these kind of backend codes. So they're basically saying this is how it's done. Preparing the payload. So when a user sends specifically crafted XML data to the application, the line, that one, allows the XML parser to load external entities. This means the XML input can include external file references or request to remote servers. When the XML is processed by a simple XML load string with the libxml node, noint, whatever option, the web app resolves external entities, allowing attackers access to sensitive files and so on. So what if we update the XML request to include references internally? We'll use the following XML instead of the above XML. So it's something like this. What if we take this right there, and we can copy paste all of it, and what we do is, well, they want us to do something, right? Don't want to skip ahead, but I could do it. When we send this updated XML payload, the first two lines introduce an externally payload, so it's going to try and read the etc host file from the host system and call that payload and sort of insert it there as a variable. So this is something that is passed and run on the backend. This is where we're going to see it. Okay, so now we have to do that. We know the feature of repeater, so we're going to send the requests on as a wish list to repeater, the one we talked about before. Scroll down and we'll place this right here manually. All of it. I don't know why it's teasing me that much, but anyways, there we have it. So it's sent, and now we can basically do what it says. So we just inserted it. It's a post request, that is true. So we inserted the new XML in the request, and now we did that. I can press Ctrl V, it's being inserted there. And then I can just press send. If you do that, in the response, let's scroll down a bit, we're gonna see what's inside the host file. What if I write pass.wd? I'm gonna get all the content of the path.wd file. What if I write shadow now, right? And this is exactly some of the problems. So that was not possible for us because, well, we don't have the right access rights. But if there are some SSH files and stuff like that, we can get it all now. So what we need to do is to go ahead and try and read the wish. And I guess we can just replace the wish right there, like that. Wish number 1, not shadow. Is it now copy pasting? Is that not to work? Because sometimes that is exactly how it's done. Go, and then get it away. Go, send it. Now we read the XML file that the Santa or the elves or the admin were able to read. And this is what we see there. And what about wish number 2 instead of 1? So we'll place that. And then see, like, we have something else and so on. So now that it's done, we can actually go ahead and read stuff. It was confirmed that the application was vulnerable and the developers were not at fault since we only wanted to give the townspeople something before Christmas. As soon as the vulnerability was discovered, XX-what-ee promptly coordinated with the developers to implement necessary mitigations. The following proactive approach helped to address the potential risk again. So disable this and that and so on. Always validate sender's input so we cannot enter suspicious input. After discovering the vulnerability, XX-what-ee informally remembered the changelog file exists within the web server application. Started the following. After checking, it can be seen that someone pushed the vulnerable code within the application after software team. So I guess we can just, take the, not click it, but we can take that one and paste it into the clip bar because that's the way it's done, I guess. And then put it into the browser. So let's go to the browser. Then we can read different kind of things. We also got a flag. So, what is the flag discovered after navigating through wishes? So wishes iterating up to 20, so we need to iterate a lot. Let's first of all try and take this flag right there. It's going to be that one, I guess, I suspect. So let's go ahead and then iterate in Burp through up to 20. I was just curious about that because it's going to be a lot of, so number 3. Now it's just a click battle. How fast can we do this? 5. We have no idea if it's 5 or 6 or whatever. So depending on this, it is just a way of telling us that we have to be patient and, send a lot of requests in order to, make this possible. So we can also try number 9 now. And the number 10, I know, it's tedious. That's the way it is. That's the way it is. So we continue until we find the flag. When the flag is then found, we're done. So 13. Let's try 19 just for the fun of it. And they said 20. Let's try that. Let's try 18. Oh my, 17. I think we all got the point now. 16. 15. There we have it, the flag. So I'm going to copy paste this and put it in. Now that we are done with the room today, I'm just briefly going to say that, I kind of like this room a lot more. It takes us through one of the very interesting, vulnerabilities that can be on websites if they use the XML parser behind. And this is the one of them that basically gonna be exploited. So if you learned something, you like the room, let me know in the comments below what you think about it, because I kind of like this one. And also gonna say ho 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 ho.